Welcome to Brad Kohlenberg from Made in Space. Where are you guys based?
We're in Mountain View, California.
Part of the reason that I asked you to chat with us today is because you guys are doing a contest with the ISS, including like Grant Imhara and Chris Hadfield, the awesome Canadian David Bowie playing astronaut, and Mauser Electronics.
Yeah, so it's kind of something we like to do where we hold these competitions for these STEM outreach activities. So a lot of what we do is we're lowering the barrier of entry to space. So now people can get hardware to space in a way that's never really been kind of available to them before. And what that means is they can now actually put real hardware in space much faster, safer, and more affordably than ever before. So we're getting really, really cool, actually really advanced concepts coming out of this program. So they're all available online. You can go and see all the entries, and it's pretty interesting.
Sweet. So that's the contest is targeted sort of towards university students. Are they the only ones who can apply? Is it open to?
Yeah, I think it is university. It says university students and engineers. So cool. I don't know if that means you have to be a university engineer or you can be just.
Yeah, it's like a logic problem there. You are addressing certain problems that exist only in 0G, which is interesting to me because we've seen printers that can print upside down and right side up, but I guess 0G is a different kind of challenge. How is that?
Yeah, so even when you're upside down, you're still in 1G, right? You're still in an Earth gravity field. So when you're in zero gravity field or a microgravity field, things do behave differently. So you can imagine like if there's weight on a belt, that weight will still be, there'll be tension on that regardless of which orientation it's in, right? But if you remove gravity, then things start to float, and even if they're upside down, there's still no tension.
But not weight.
Yeah, so there are things that you can only really tell in zero gravity, or things you can only really test in zero gravity because of that.
And you guys have done a bunch of like suborbital, like vomit comet flights on that, right?
Yeah, exactly. So they like to call them weightless wonder flights. That's the NASA term.
That's a little more glamorous.
Yeah, but yeah, no, that's exactly right. So we flew in a series of parabolic flights to get little microbursts. You get about 20 seconds of microgravity for every parabola. And so then you can kind of test your printer or your whatever you're working on within that kind of little time window. What we did, because it's really hard to print for 20 seconds at a time in microgravity, we actually designed the printer to print throughout the entire flight profile. So it's actually less of a zero gravity printer and more like a gravity independent printer. So it can print in 2G and 1G and 0G, and as those gravity fields are changing, its print is consistent.
Coolio. And then you also have to deal with potential hazards. Like you have to be really careful about particulates, I would imagine, being on the space station, like with all filtered air and stuff.
Right. So maybe even more of an engineering challenge than getting something to work in zero gravity is getting something safe enough for use on ISS. So there's a lot of safety considerations, and safety is NASA's #1 concern. So yeah, nanoparticle proliferation, toxic gases, things like that were hugely important. And so we actually had to create a filtering system for the printer so that the air coming out of the printer is actually cleaner than the air going into it. We basically kind of went through dozens of different filament providers to find one that worked kind of the best in terms of consistency and just didn't give our printers that much issue. And so then we selected that, and now we're reselling that to interested parties.
Awesome. And you're working on some kind of recycling process so that you can reuse it. Is that right?
Right. Yeah. So so there's a couple ways you can save mass and volume, and one of them is just by 3D printing itself. Right now, everything we put into space is over-engineered just to survive that 10-minute ride to space. But then for years being in this weightless environment where it doesn't need to be, over-engineered and robust and strong, it can be very light and delicate. It just had to be strong to get there in the first place. So if we know that we can just by 3D printing start to print these things, that the end use, the ultimate like end kind of design is these very light 3D printed structures, just because they didn't have to survive a launch. So you're already getting to kind of save mass that way. But then, as you pointed out, yeah, if you can start to recycle these materials, and when they break or are no longer needed, you can turn them, into something else that you do need, then that just makes it that much more sustainable And if you can imagine going beyond Earth orbit and going to Mars and things like this, where things are, a year away for delivery time, then you can really imagine the kind of the importance of kind of sustainability and reusability. Two of the more requested items from the astronauts, which are kind of interesting that you might not expect, are spoons and back scratchers. The two most requested things. So I might maybe design something that's part spoon, part back scratcher. I don't know. Yeah, it is funny. Just all sorts of things, like day-to-day things that you take for granted that become actual, like, real challenges up there. I think one of my favorites right now is they 3D printed an attachment so they have a vacuum up there, and it's not just like a regular off-the-shelf vacuum. It's like some specialty vacuum that some aerospace prime contractor had built for them. And so they have various attachments for this printer. And so they wanted to create a new attachment for this vacuum for a very specific use case. And I guess the other attachments they had just didn't really work that well. So we designed and created this just, plastic attachment for the end of their vacuum hose tube. And they were able to use it, and it worked out. So that was pretty cool. We're already starting to print neat little tools and adapters and parts that, we never imagined we would be printing. So it's already starting to kind of like change their lifestyle up there in ways that we didn't predict, which is really cool.
Awesome. Is there anyone who particularly like hassles you for stuff? Who's always like, 4 a.m. like you get this email like, hey, can I get this thing? Like, who's the biggest hardware 3D printing nerd on the space station?
So that's a really good question. I would say no, we don't. We haven't gotten too many emails like that from the astronauts.
How do you talk to them? Is it email?
Yeah, so we talk to them through NASA. There's a NASA crew office that kind of handles the communication to the crew.
Cool.
So a lot of what
they're just out there with mirrors at night doing whatever.
Right. Yeah. We don't get any like SOS signals or Morse code from ISS from them yet. That would be pretty interesting. But a lot of what we're doing is stuff that NASA plans for them. So it's less the astronauts' input and their requests or desires, and more like the research or the kind of career activities that NASA wants to perform.
Are you more of a space nerd or a hardware nerd or both, or what?
Yeah, I'd say I'm definitely more of a space nerd. And then maybe after that, software nerd. Less hardware, but I am very jealous of the hardware people because they can like build real things in the real world, and that's always cool.
Yeah, I'm definitely more on the space nerd part of it, but someday it'd be cool. I'd love to go to space. I think we all would.
Yeah,
that overview effect.
Yeah. Have you checked out Space VR?
Yeah, I've not tried it out yet. Have you? I don't know if it's released yet, but maybe you get some like early peeks or something.
Right. Yeah, I helped back the Kickstarter, so I don't think they've launched anything or released anything yet.
I'm really excited about that. I'm gonna subscribe as soon as like you can get in on that. Exactly. It's gonna be awesome.
We talk a lot about our 3D printer, and that's kind of like our big claim to fame, and that's what kind of put us on the map. That was like our first thing in space and our first like step towards our ultimate vision. Our name isn't 3D print plastic on ISS. Our name is made in space. So we really do want to make the things in space that we've always dreamed about. Things like space elevators or USS Enterprises or Death Stars or whatever it is. Like, you can't launch those things from planets. You have to build those things in space. How do we learn how to do all those things? How do we learn how to build structures and electronics and all these kinds of devices in space? So we recently gotten contracts from NASA to work on something called the Archinaut, which is like architect astronaut. But it's essentially this autonomous robot that will take the lessons we've learned from 3D printing and allow us to start doing additive manufacturing outside the station and do, hopefully eventually do kind of kilometer scale structures in space, things you could never ever launch, right?
Holy crap.
Yeah.
So why build in space? Why would you make this?
A species either becomes multiplanetary or goes extinct. So we have a pretty big need to learn how to live off of Earth, permanently and sustainably. And as long as we can, continually launch manufactured goods from Earth, we're never going to be able to do that. So if we can start to, manufacture goods in space where we need them, when we need them, then we get that much closer to being able to survive any kind of calamitous impact Earth may have in the future. In the near term, it really does allow us to do things that we've only dreamed about. So imagine telescopes that dwarf Hubble or dwarf the James Webb telescope, even things that are just at scales that we have only imagined, and at scales that are completely doable in space. Space is vast, and you have all the room, and you have the vacuum and temperature and all these things at your disposal. So if you want to do space-based power or space habitats or anything like that, we can't just keep like unfolding things from little tubes. We eventually have to start going beyond that. So this is kind of steps on that path towards doing that.
That's awesome. Steve, thank you so much for sharing with me.
Yeah,
I hope you have an awesome rest of your Wednesday.
Yeah, thank you. You too.